Hi, I'm Jace Hershberger. I'm the Audio-Visual Manager for the AT&T Performing Arts Center.
My name is Matt Pearce, and I'm a Technical Coordinator for the Center.
My name is Jonathan White, and I'm the Head Audio for the Center.
We are leading today's Tech Talk, part of our Backstage Spotlight Arts Education program.
While we usually prefer having students visit us at the Center, we're taking Backstage Spotlight online so you can experience our technical theater training from home.
Today, we're taking some time to introduce you to the basics of professional audio. Every person has a different background, and this is especially true with audio. Working with people of different backgrounds, experiences, and knowledge is very common. This is an important part of the creative and technical process for live audio.
So a little background on the three of us. I started right out of high school, working at a small professional theater in Ohio, where at the same time I was doing a lot of freelance work from setting up big festivals to some corporate events. After a few years of doing that, I was hired by a cruise line as the audio technician, where I got to travel the world and work with big Broadway shows, Vegas-style musicals, some vocal groups, rock bands, magicians, and a lot more. Now I'm back on land working here as the AV manager, where I get to handle daily operations, A1 for center-produced shows, and overall maintenance of the equipment.
I started out working in my university's project studio recording ensembles. After a semester, I landed a job working as a head audio at a local theater. Since then, I've done a lot of freelance in both live and recorded audio for corporate, dance, live music, and theater. Now, as a technical coordinator for the center, I primarily work as the A2 for center-produced shows and handle day-to-day maintenance and labor.
I started working with live audio in middle school by setting up sound systems for live performances and events. That progressed into high school, where I expressed interest in drama club and mixed live microphones and tracks for my first performances. After high school, I started working with local bands, mixing shows and engineering recording sessions. I also worked for a theme park, engineering several shows per day inside a venue. I started working for the Center 5 years ago. Today, I am the head audio, or department head, for the Winspear Opera House. I maintain audio and video systems, engineer shows, and work with touring audio staff to ensure high-quality, intelligible sound.
When getting into live audio, it's important to understand signal flow. Understanding how to get a sound from point A to point B will help you see how, and more importantly why, audio equipment is utilized. Our job is to get sound from the stage to the audience. Understanding the basic parts of a sound system is important to know how to make that happen. We won't go too far into detail, but here are some of the basic parts of the system. There are simple things, such as microphones, like what I'm using to talk to you. Microphones and other inputs use certain cables to get signal from one place to another. Inputs are plugged into a console, which is what we use to mix signals like microphones and computers. This mixer can be very simple or highly sophisticated. It can be analog or digital. In any case, these inputs get mixed down to outputs, like loudspeakers for the audience, monitor wedges for performers, and broadcast feeds for people watching at home.
For theatrical shows, there are a lot of people that focus on sound. For example, a big Broadway show, there are lots of people you won't see at the show that have worked really hard to make the show sound the best that it can. The first people to work on big shows are designers, who take the concepts from directors and develop the themes that the show will use. When a designer is ready to work with the equipment, they work with the engineers and programmers, who take the designer's concepts and apply them to the technology and the venue. From there, the show is rehearsed and refined and eventually sent out on the road to be presented in theaters.
Live music uses a lot of the same equipment as theatrical shows. However, instead of an orchestra and singers performing choreography, we have musicians running around the stage with guitars, loud drums, and lots of fans singing along. There normally aren't designers involved. Audio engineers instead work with the band to get the system sounding the way they want. In a large majority of live music shows, there are multiple engineers working at the same time. One engineer is working at front of house, mixing the band for you, the audience. There's also a second engineer, working with the same inputs, but mixing lots of different outputs so the band can hear themselves and the other people on stage. There are also engineers that work with movies, corporate events, broadcast, radio, religious organizations, and many other applications. In general, they're all using similar equipment to accomplish their jobs.
Since we're not at the center, we can't show you the equipment we work with every day. Instead, we'll work with a song and software to show you some of the ways we can change how audio sounds. Since we're all working from home, Jonathan will be our DJ for today.
Since we're using software to show you how we work with audio, what we're showing you doesn't look like a real console. This software is professional audio editing software that people like recording engineers use to mix tracks that have been recorded or will be recorded. You can see that along the large middle section is a track. This is like an input. It's audio signal that we will be working with. If we were to record what I'm saying right now in this software, you will see my voice moving a tool called a meter. This meter shows you how loud or quiet a track or an input is. A lot of consoles have meters, so you can see how loud each input is. If you can hear that an input is too loud, you can visually look at your meters and find out what the problem is. At the bottom, we can see our track or input again, but instead of seeing the entire track laid out, we can see the controls for the input. Each track in this software, as well as inputs on a console, has a fader. Fader is a fancy term for a volume knob. Just like the volume controls for your computer, phone, or other device you're using to watch this video, every channel or input that we control has a fader. It controls how loud something is once it's plugged in and set up on our console, or in this case, our software. When we're ready to start mixing a live show, we normally have a sound check. This is when we have the band play their instruments so we can make sure everything sounds right. Sometimes we don't get a sound check, so we have to figure things out once the show starts with the audience in the room. Most of the time, though, we can get everything dialed in before we have patrons in the room, so it sounds good from the start. Now, because we're working with a track that's already been recorded, we'll pretend that when we press play, we're starting sound check.
Okay, so let's start the track. Notice that we can't hear any audio. Look to your input fader, and let's bring that up. Great. So we can see we're getting an input signal, but we're still not hearing anything. Think back to what we know about signal flow. Inputs go to outputs. Notice our output fader is still down. Let's bring that up.
Alright, so now that we can hear the track, let's go ahead and open up the equalizer. The equalizer, or the EQ, gives us the control to be able to make changes to the different frequencies of this track. This EQ is laid out with the low frequencies starting at 20 Hz on the left to the high frequencies at 20 kHz on the right. So if we start with the lows and we make a cut, you'll start to hear the difference. We can take that low cut and we can start to move it towards the right, the highs, and you will hear that we're only left with the high frequencies. We can also do the same thing starting from the highs and work our way down. This is more dramatic than how we would use it in a live situation, but it gives you a good example of what the EQ can do and how it really affects the sound.
Once we get the input sounding the way we want to, we can add effects to the signal, such as delay, and reverb. But also specialized effects like
pitch shift
and auto-tune.
These are just the basics. Most modern consoles have many more features that allow the engineer to work with inputs to create great sounding shows. There are often tools inside the console to make the engineer's job easier and more efficient. Most modern digital consoles actually use a computer inside of it to function. If you see a big console with lots of screens, it's probably using a computer to work. You'd be surprised how easily a big console can use a small computer running an old operating system. We use the term console and mixer somewhat interchangeably. If we say console, we're referring to the sound console, soundboard, mixer, or desk. They all mean the same thing. Engineers, or people who mix sound, use consoles to work with inputs and outputs to make shows and events sound good. It's difficult to find out what the first live sound console was, but almost everyone agrees that it was actually several consoles used together to mix a band, since this technology was stolen from recording consoles. As consoles got bigger and heavier and more expensive, their ability to mix more inputs and do more things with those inputs increased quickly. Now that we've talked about the basics of what we can do with sound, let's show you how to plug in a system.
The typical way to get sound into a professional audio system is through a microphone. Very simply, a microphone is a device that takes sound and transforms it into an electrical signal, which is sent through XLR cables to the audio console. The two most common types of microphones are condenser and dynamic mics. When choosing between them, consider your application. If you're miking a loud source, something with a high sound pressure level, or SPL, like a snare drum, you'll want to use a dynamic mic. If you're trying to capture a delicate source with more detail, say a vocal with some of the air around it, you'll use a condenser. As with most things in audio, this is never a hard rule. Once you've chosen your mic, properly place it at your source, and run the cable to your mixing console, you're ready to send a signal to your engineer.
The Winspear's primary console is the Soundcraft VI7000. This large format digital console uses special cable to get inputs and outputs to and from the stage. We can get 64 inputs from the stage to the console using a single specialized cable, which makes it really easy to move these consoles around, rather than having to carry lots of really heavy cable for every channel individually. We have two of these consoles, so we can have two engineers working with front of house for the audience and monitors for the band. In order to do this, we use something called a splitter, which does exactly what it sounds like. This piece of equipment takes an input, like a microphone, and splits it so we can be sent to different places at the same time. These splitters are very common. They're used every day to make it easier for engineers to do their job. Otherwise, we'd have to put two microphones out for every input. Can you imagine?
For the rest of our indoor venues, we utilize the Yamaha LS9-32 and the M7CL48. These digital consoles are easy to deploy and are suitable for most of our needs. Both of these consoles use similar software, so switching between them is a relatively easy task. The primary difference is the hardware. The LS9-32 has 32 inputs, where the M7CL48, you guessed it, gives you 48. Notice how the consoles are laid out. The M7CL has all of its input faders readily available, unlike the LS9, where the faders are stacked into what we call layers or pages. For our outdoor venue, Annette Strauss Square, we'll use our larger console, the Yamaha PM5D.
When deciding on loudspeakers, you got a few choices to make. First decision is whether you need a point source or a line array system. Point source speakers are typically a single speaker you put on a stand for a smaller audience. They're easier to deploy and operate, just point them at the area that you want to cover. Line arrays are a bit more involved. There's a lot of science that goes behind deploying a line array correctly, but their purpose is to cover a large area as evenly as possible, so everyone can get a similar experience, even from far away. Next, you'll need to decide between active and passive speakers. The difference is simple. Active speakers have a power amplifier included inside the speaker, where a passive requires a separate power amp. Both have their pros and cons. Active speakers are great if you have limited space or just a few speakers to cover your audience. In most large-scale venues like the Wiley Theater or the Annette Strauss Square, we use passive speakers. But just to prove this isn't a hard and fast rule, the Winspear Opera House uses active speakers.
Now that we've talked about some basic hardware, we can show you some of the fun stuff that we do every day. Our day-to-day jobs are filled with a variety of shows and events. I think the three of us can agree that we got into live audio because every day can be different. One day, we may be making cable for 8 hours straight. The next, we're mixing a full orchestra. Another day, we may have a beautiful wedding in one of our spaces. It's very common that all of our spaces have shows at the same time, which means that we have to make sure we're talking to each other to know where our equipment is and who's using it.
Since we have so many spaces, and it's so common for all of them to be running at the same time, we have to make sure everyone on our technical staff can run basic sound systems. Even a smaller show, like one person speaking to a group of people, requires a full audio system. Microphones, a console, loudspeakers, and of course, an engineer.
That's it for today's segment of Backstage Spotlight's Tech Talk. We want to thank all the foundations and donors who make the Center's arts education programs possible. We couldn't do this without you. If you'd like to help the Center offer more programs like this, please visit atpac.org/support.